Hello, it's Keith here, and this is day 4 of the Grime 68000 project. So how are things going? Well, if you're looking at the screen, you can probably see that there's some grime going on, which is quite good because it's the title of the game. So let's have a look at what's actually happening. So you can see if I pick up the correct controller, I can control the game, and the grime is moving around. But I can't die yet, so the game is coming along quite nicely. No dying, no score. No lives, no title screen, but I think that's not going to take too long because based on Grime 6502, that all came in pretty quickly. So I think we're doing okay here. I did, however, come across some problems with programming today, though, and I will talk about those in just a moment. But first, let's just check all the versions actually work because, as I say, I came across some unexpected problems with some of the systems, but I think, to be honest, it was the Atari ST and the Amiga that were the problem systems, and the other systems were okay. But I'll discuss that again in just a moment. So yeah, that looks like it's working the same. No. My psychic powers tell me the other one that could be problematic is the X68, so let's see how that's doing. It looks okay, that's good. Let's try the Gen. I don't think I've got the Descenders programmed in yet. I can't remember. I'll have to check that. Maybe not. Anyway, you can see it's working okay on the Genesis. And then just finally the Neo Geo. Some of these games I'm controlling by keyboard and some are joypads, so I keep pressing the wrong buttons. But anyway, that's user error. The game is working okay. So you can see, basically, we've got the graphics working on all of the systems. The game is, semi-playable in the sense that the game is working, I think, correctly, but there's no lives, no score, no game over screen. So that's, basically what I'm going to be working on tomorrow. So that's the state of the game as it's playable, and that's what I'm going to be working on tomorrow, just getting the rest of the game basically finished as fast as I can. So what's been going on? Well, obviously I've been converting over the Grime code. One thing I have realized, I sort of said the other day that the compare command worked the opposite way on the 6502. I think I was incorrect in that. It does actually work the same. It's just in some cases you can actually flip the two parameters around because you can compare two registers to each other. And I think I was just misunderstanding the order of the registers, so to speak, because you specify both of them in 68000, whereas with 6502 you're always comparing to the accumulator. But anyway, that was only a small thing. I had a few problems with regards to working at bytes and words and things, but that's often a problem with 68000, and that was just my own stupidity. The real big problem I did come across, though, was with regards to memory. Now, I said, I think last time, that the 68000 systems, you can't have as much control over the memory as you can with Z80 based systems, and the 68000 just kind of gives it to you by itself. The operating system does that for you. Now, that's not true on systems like the Genesis, where the RAM is a fixed area, and also the Neo Geo. Now, I do my primary development on the Genesis, and the reason I do that is it's very fast to start up. If you look at an Amiga, if I just start the Amiga version, now the Amiga emulator is now starting up, and I've tried to turn warp mode on, but even in warp mode it doesn't even come to the command line very fast, and I don't know how to create an auto booting disk, so I then have to type start. So getting the game starting is quite slow, whereas if I do it on the Genesis, instantaneous. So I do my primary development on the Genesis, then I test on the Neo Geo, then I test on the disk-based systems. The X68 is a bit faster, the emulator starts a bit quicker, and I can use the turbo mode more effectively, and I've got an auto booting disk. But anyway, the reason I'm talking about all of these different emulators is the Genesis and the Neo Geo, the memory is a fixed location, whereas the other systems are being allocated memory by the operating system. The problem I was having was that the invaders were flying across from the left-hand side and then disappearing at random points in the screen on the Amiga and the Atari ST. Well, they weren't random points, they were fixed points, but different fixed points on both systems. And what was happening was very obvious to me. Now, if you look at the invader code, I'm doing AND on the memory address of the tile map. You see, I scan through the tile map in a consecutive order, and then when it comes to working out the position of the invader, I'm using the bottom 5 bits to work out the position. Because the tile map is 32 bytes wide and the screen is 32 tiles wide, I should be able to take the last 5 bits of the byte address of the memory and use that to work out the X position of the invader. That works as long as the memory is byte aligned, which it is on the Genesis because I'm taking the memory from a fixed location. However, on the Amiga and the Atari ST, I don't know what memory I'm going to be given. I could be given anything, and so that was causing me a real problem. And what I've done is I've added an extra 256 bytes to the start of my game RAM area, and then what I've done is I've changed the code that I'm using to read in the tile map address. It was already a bit complex. I was using this load effective address, which tells the operating system, well, what memory did you really give me, you know, for this thing. And so I was already using that, but now I'm doing a bunch of extra commands, which is quite annoying me, but I am. So I'm loading the effective address into A2 because a load effective address only works on address registers. Then I'm moving the address register to a data register. Then I'm doing an AND command, stripping off the bottom 5 bits to the data register. And the reason I'm doing it to the data register is you can't use the AND command on an address register. And then I'm moving it back to the address register so I can actually use it. Now in this case I'm also adding 4, but that's to do with the centering of the tile map. If you look at the other examples where I'm doing this game, you can see that's not there. This is the more typical one. Load the tile map address into A3, move A3 to D3, wipe out the bottom 5 bits so that they're 0 aligned, save it to D3, move D3 back to A3, and this is the quickest way I've figured out of doing it. Now maybe there's a quicker way I don't know about. I was kind of taking as my example this here, which is the Atari ST example code I took to learn how to do the bitmap screen, and it's doing something very similar. It's basically wiping out the lowest byte of the address of the screen memory, and it does the same, allocating an extra 256 bytes that it doesn't really need. And as I say, because I'm putting a buffer of 256 bytes, I know I'm not going to be wiping out anything that's really important. Technically, this could have just been 32, but you know, we're in the 16-bit territory here. You know, allocating an extra kilobyte of memory isn't going to affect anyone. So you know, it's I'm playing it safe, allocating 256 bytes when I actually only need probably 32. But I'd rather have fewer crashes and less testing, mainly because, as I say, some of the emulators take a heck of a long time to start up, which is very annoying, and maybe I'll manage to figure out better ways of getting the emulators to start up, but I haven't done it yet. So let's just have a quick look over the code and see what we've done today then. So the game loop code is a little bit more complex now. We've got the mold move and the evolve routines. We've not got that descender yet. We do need that descender, but that's going to come. Unless I've actually already done it, have I? No, I haven't. I couldn't remember if I'd created the code or not. It seems I haven't. So I'll have to get that working. So this is all basically not changed, I believe. But when we get to down here, the evolution code. So one mistake I made quite seriously, when I'm doing my comparisons, I need to do compare.b. If I don't do that, I think it compares at maybe the word level. But anyway, I need to make sure I'm comparing at the byte level, because otherwise I'm going to have loads of malfunctions. One thing I found quite frustrating, which surprises me because usually 68,000 is always easier, and that is I'm used to Z80 where you've got a call if zero or non-zero command. There's only a branch equals or branch not equals, so there's no jump subroutine command based on a condition, so you have to do branches to skip over, and that's quite a surprise to me because generally 68,000 is easier than Z80 and 6502, and this is one case where Z80 has a command that 68,000 doesn't seem to have exactly the same, so that caught me out a little bit. I made a mistake and did all of these as branch not equals instead of calls, and that really screwed up my code obviously, but I got it working now. But you know, basically it takes a long time to convert the code. Ironically, it takes longer than 6502, part of it being all the registers are numerical, so they're harder to remember, whereas the 0-page virtual registers on 6502, I was giving them sort of sensible names. But I think that's going to get better, because as I'm doing this, I'm already remembering that D1 is my equivalent of B and D4 is my equivalent of C, so I'm sure it'll become second nature fairly quickly as this project progresses. And as I've said before, I'm planning on doing 68,000 as a sort of permanent development project, so it's not like it's going to be something I'm going to get worse at. So hopefully it'll just become second nature, which will be nice. Because as I say, it is a good language. It's got some fun and some power. I'll tell you one thing we should have a look at is random. Get random command. Now, I'm sure the 68,000 systems have got very advanced random number generation built into their operating systems. I can't say I know how to do that yet, but I thought just for some fun it would be more interesting to convert the 6502 random number generator, and that's what I've done. So let's have a look at it and let's compare it to the real 6502 random number generator. So here they are side by side, and the first thing you should notice is that the 68,000 one is tiny compared to the 6502 version. So let's have a look at it line by line. So first we're loading the random source into address register 4 here, which is kind of the equivalent of this. Now we're moving the data from the random seed into my fake accumulator here, and we're taking the 3 bits here. So this is these commands here. But you'll notice there's no transferring of A to Y or anything like that, because when it comes to actually reading in data from the address with the offset, we are doing it with this command here. And what this command says is load in data from address A4, register A4 with an offset of D0 plus 0. Now this is just a sort of fixed number, so this is a constant. Now the reason it's there is when you use this address register with deregister offset, you always specify an integer offset, I believe. So if you don't want one, you just put a 0, which is what I've done there. So we are loading from that combination of A4, D0 and the 0 here into a register D7. So this here is doing the work of this and this. So this is really quite kind of the power of it. And of course, we're not just limited to sort of 1 byte or offsets or anything. And you can see there's another one here, which is the equivalent of this one here. And that gives us a lot more power. And of course, because we've got so many registers, it's all a lot simpler as well. Instead of AS, we're using D7. We're also using D6 as a temporary register here. We're doing an AND of FF here at the long level. This is making sure that D0 is returned with a value from 0 to 255, because as I've said before, all the registers are 32-bit, and you don't want to start having junk floating around in the unused bits, because if you forget and accidentally use it as a long somewhere, you're going to end up with a right mess. So just for safety, I've done that. And then here we're just incrementing random seed and random seed 2 using add quick at the byte level, because this is a 1 byte parameter, of course. So these are the equivalent of these here. But actually noticing this should be 3 inks, so I've made a mistake there. But I can just change that to #3 here, and that will do the job. So as I say, this is another time that 68,000 is much more efficient. This command converts to a single command. Now, I think the commands are 16 bits in 68,000, whereas on Z80 and 6502 they are 1 byte or 2 bytes or 3 bytes. I think they're all 2 bytes on 68,000. I may be wrong, it may be 4. I'm not really an expert on it. Unlike with Z80 and 6502, you don't really tend to do much self-modifying code on 68,000, whereas you tend to start to learn the byte equivalents of commands. I've got sort of cheat sheets to look them up in. You could, in theory, do that with 68,000, but to my knowledge, no one does, and the numbers would be huge. So, as I say, I think they are 16 bits, the commands, but I may be wrong. Anyway, you can see here we've got very similar commands. EOR is the same as EOR here, or XOR on the Z80. Load effective address, because again, we can't just move addresses straight to registers, because we can't rely on where they're really going to end up. So I'm using LEA for safety, which seems to be the only safe way to do things. But you can see in general that it's all pretty straightforward, relatively similar to the 6502 code. I mean, with the exception of these quite crazy and fairly impressive addressing modes that the 6502 definitely doesn't have. It's effectively the sort of supercharged equivalent of this here, but much more powerful because you've got many address registers and many data registers, and then you've got fixed offsets to that as well. And this is only 68,000 code. There's the 68,000 and 10, 20 and 30 which have more advanced commands even than this, but in my videos and my tutorials I'm only going to cover the basic 68,000 code. The reason being that if you've got a more advanced processor, using the old commands will still work, but we're just trying to have some fun with these old systems. We're not really trying to write the most efficient code possible on them because they're old systems. It's just, let's have some fun with them. I'm not trying to go to sort of crazy extents of using all the most advanced commands on these systems because it's really just not what I'm looking to do at this stage. So anyway, so there we go. That's the state of the code as it is today. Challenge for tomorrow: make as much of the game work as possible, basically. So the first thing I want to do is get the death in, get the game over screen, I guess, get the scores in if I can, get the title screen finished. It's really just waiting for a press fire and showing the high score, I guess, so that's not too much work. But that's the main challenge for tomorrow. The animation doesn't work either, I suppose, but I'm not too worried about that. But anyway, let's just hope no more quirks come up with regards to memory mapping like came up today with regards to that problem of the memory positioning. There was all kinds of crazy things going on with that because at one point I broke all of the versions because I'd made a bug in my references at the top, and the second time up and the first time up were overlapping each other, I think, but it just wasn't working. And the problem is, having never done this before, it's kind of becomes, I don't, where's my safe zone? I don't know if the command I'm using to try and fix this is right. I don't know if the procedure I'm trying to use to fix this is right. I'm not sure what the best solution to this is, and I'm, in some ways I wasn't even sure if my theory of what the problem was really what the problem was. But anyway, we seem to be in the clear so far, so hopefully it'll still go okay. Anyway, thanks for watching today. I hope you've enjoyed it. Please tune in for the next episode. Thanks for watching and goodbye.